My name is Flash Isaac, and I'm a teacher from the future. When I was much younger, I saw thousands and thousands of people fail Jamb and unable to gain admission. This made me travel in time. Now I am back with the Flashlearners Jamb app and a series on YouTube tagged 120 Days to Jamb. My mission is to help you blast Jamb and as well get justice for everyone who Jamb has served breakfast. You are still watching 120 Days to Jamb Physics with Flash Isaac. In this episode, we shall be looking at the photoelectric emission. In the previous episode, we analyzed the thermionic emission, where we agreed that thermionic emission is emission of electrons or radiations when heat is applied to surfaces. It can occur in solids, in gases, and in vacuum. The advantages of thermionic emission in gases over vacuum is that 1. Larger amount of current is transferred. It can be used as cooling agent and there is improved efficiency. But thermionic emission in gases have one disadvantage in the sense that larger electrodes are used. Since larger electrodes are used and for vacuum smaller electrodes are used, therefore that is an advantage of thermionic emission in vacuum over gases, because in vacuum at least smaller electrodes are used. We are looking at photoelectric emission. Photoelectric emission can occur in solids, it can occur in liquids, and it can occur in vacuum. If thermionic emission, thermo heat emission, photoelectric will simply be photo light emission. Now, the emission of electrons from surfaces bombarded by light is referred to as photoelectric emission. If you have surfaces and you bombard light, you shine light on it, it will emit electrons. As such, that is photoelectric emission. Now, why would a surface emit electron when light is incident on it? This is because there is elastic collision between the incident light, photon, packet of light are referred to as photon, and the electrons of the atom of the materials. A question comes to mind. If I now take a torch and shine on a surface, will electrons be emitted? Yes and no. There are factors that determine whether electrons will be emitted or not when light is incident on surface. These are the conditions. For you to get electrons or radiations when you shine light on a surface, 1. The frequency of the incident light. Let's say this is your light. This is the surface. This is your light, right? This is your light. This light intensity is the frequency. So the frequency of this your light must be greater than the threshold frequency of the material or the work function of the material. Work function or threshold frequency of the material is the minimum frequency or minimum energy. Yes, the minimum energy you need to emit electrons on that surface. If your intensity of light is not up to the minimum frequency that particular material needs to begin to vomit electrons, then electrons will not be emitted. So, for there to be photoelectric emission, the frequency of the incident light should be greater than the work function of the threshold frequency. If this frequency is lesser than the work function, electrons will not be emitted. What if it is equal to work function? There will not be emission of electron. However, it can be set free, but there won't be movement. The second condition is that the incident wavelength should be lesser than the threshold wavelength. Now, this incident light has frequency and it also has wavelength. Since frequency is inversely proportional to wavelength, as frequency increases, wavelength will reduce. Therefore, we need this incident ray or incident light to have smaller wavelength than the threshold frequency. If the wavelength of the incident light is small, as it gets smaller, we will have enough frequency. And remember, we need enough frequency to overcome the threshold frequency of the material we are trying to get electrons from. Also look at this. The electrons emitted from this surface is referred to as maximum kinetic energy. That is the energy emitted from surfaces of materials in photoelectric emission. So, how do you find the maximum kinetic energy? The energy is Hf. H is Planck's constant. You will be given in questions, and F is frequency. So, if you are given Planck constant and frequency, you can always find energy. Questions under this part are usually easy. This is why you need to get the Flashlearners Jamb app, select all these topics, and see questions. Now, frequency is speed of light over lambda. So, maximum kinetic energy is also equals hc divided by lambda, which is wavelength. So, the formulas for maximum energy emitted or energy emitted are E is equals Hf or E is equals Hc over lambda, that is wavelength. Another factor or condition that determines the emission of rays is the color of incident light. Color of incident light affects photoelectric emission. Do you know why? Different lights, different colors have different wavelengths. Look at this. This is the order Roy-Beeve. Red, orange, yellow, green, blue, indigo, and violet. Red has the highest wavelength, while violet has the smallest wavelength. So, in the order of wavelength, it is Roy-Beeve for light: red, orange, yellow, green, blue, indigo, and violet. Work function of the material determines photoelectric effect. This is because the maximum kinetic energy, which is the energy emitted, is energy of the incident minus the work function. Photoelectric emission also depends on the nature of the metals, because different metals will have different work function. A metal with smaller work function will easily emit electrons compared to a metal with a very high work function. And the applied potential difference or voltage affects photoelectric emission, because E is equals Hf and it is equals EV. Energy is equals EV. And a major factor that affects the number of photoelectric emission is the light intensity. Light intensity affects the number of photoelectric emissions. Now, what are the applications of photoelectric emissions? How does photoelectric emission change the price of garri in the market? 1. Photoelectric emissions helps in photography. In every lens or camera, you see what we call aperture, lens, and sensor. All these, they adjust to make sure that as many light as possible enters the camera, because the more the light, the more you're able to get a good picture quality, other factors being constant. So light plays a very important role in photography, and its fine application in photo cells. These are cells that work based on light, and in burglar alarms we apply photoelectric emission. It also finds application in generation of electricity, which is referred to as photoelectricity, getting electricity from light. Photoelectric emission is also used in automatic control switching, like automatic opening and closing of doors. In summary, some of the applications of photoelectric emission are photo cells, photoelectricity, burglar alarms, automatic control switches, and photography. Ladies and gentlemen, with these few points of mine, I hope I've been able to tell you one or two things under photoelectric emission. See you in the next episode. And make sure you subscribe to this channel if you've not. Tell your friends and everyone about the Flashlearners YouTube channel. Take care of yourself and see ya.